Hello students, all good? Today I am here with the topic triangles from class 9. In this chapter you are going to learn about the congruence of triangles, rules of congruence, and inequalities in triangles. Inequalities in triangles. These are the concepts that we are going to discuss in this video today. Okay, so before moving on to the discussion of these topics, let us try and understand what is a triangle basically, which you have learned already in the lower classes. We'll just have a recap of that. Okay. Now, what is a triangle? A triangle is a closed figure, a three-sided closed figure. A triangle is a three-sided closed figure which has got three sides, three angles and three vertices. This we all know, right? Triangle is a three-sided closed figure which has got three sides, three angles and three vertices. Now, shall we just discuss what are all these? Three sides. Sides are here, the three sides are AB, AC, AB, AC and BC. Fine. And this is called as the point where two lines intersect or two sides intersect is called as a vertex. The point where two sides intersect or meet, or you can even say touch each other, is called as vertex. Okay. Now how many are there? A, B, C. Three vertex. Each one, when you say one, it is in singular, it is vertex. In plural, I have got three now. So it is plural, right? So I have got three vertices. They are A, B and C. Right? Now, there are three angles formed between pair of sides. That is angle A, angle B and angle C. Angle A, angle B, angle C. So these are the basics about a triangle which you have already learned. So we just had a recap now, right? So what is a triangle? I repeat, a triangle is a closed figure which has got three sides, okay, three angles and three vertices. Fine. And always the vertices are marked with or labeled with capital letters. Now let us discuss the congruence of triangles. Now let us discuss the congruence of triangles. What is the meaning of congruence or congruent? What is the meaning of congruent? Say for example, now I have a circle here, right? And then I have a square here. These two geometrical shapes are different. You all know that, right? This is a circle and this is a square. Their shapes are totally different, right? The shapes are different, then there is no point in talking about the size, right? Now, say if I have two circles circle 1. Say this is circle 1 and this is circle 2. Now we'll compare these two. Okay. When you compare these two, they are of the same shape, right? This is also a circle, this is also a circle. Both of these are circles, right? But are they of the same size? No, right? The shapes are same, but size is different, right? Circle C1 size is different from circle C2, means their radius is different, right? So they are called as similar figures, but they are not called as congruent figures. They are only called as similar. They look the same, right? That is why we call it as similar figures. They don't have the same size. They only have the same shape. So we call them similar figures. But this circle and square, we cannot even call them as similar figures because they are not similar. They don't look the same, right? Circle is different from a square, right? Now, we can only call these as similar figures. Now, let us see what are congruent figures. Now, if I have two squares of same shape and say here the side is 2 centimeter and here also the side is 2 centimeter. Now compare these two. These two are of same size and also same shape, right? Now the measurement of the side of the square, you all know that all the four sides of a square is equal or are equal, are equal. All the four sides of a square are equal. So if this is 2 centimeter, all the other remaining three sides are 2 centimeter. Similarly here also. So both these are squares, same shapes, and both these are of the same size. So these two are called as congruent figures or congruent squares. Okay, so understood what is the meaning of congruence? Congruent means in all respects, two figures must be the same. In all respects, two figures must be the same. That is the shape and the size. Now let us come to triangles. Okay. Hope you have understood what is the difference between similar figures, non-similar figures and congruent figures. Now, take two triangles, triangle ABC and triangle DEF. Okay, now I have taken two triangles ABC and DEF. Now, when can I say that these two triangles are congruent? When their shapes, of course, both are triangles, their shapes are same, right? Their size also should be the same. Okay. Now, what does that mean? When I overlap, when I take triangle ABC and triangle DEF, when I keep one on top of the other, that is when I overlap, the other, only one should be seen, the other one will be hidden, right? Any one, let it be ABC or let it be DEF, whichever is on the top, it hides the one which is behind, right? That is how the congruent figures will be. Fine. So that, and when I place this DEF on ABC, my ABC should be hidden, right? Why it is getting hidden? Because the corresponding sides are equal, right? Now say if I am placing this DEF on my ABC, D will be on A. So D and A are corresponding to each other. Vertex B is corresponding to vertex E. Vertex C is corresponding to vertex F. Right? Now sides. Since I keep this DEF on ABC. It overlaps, right? What happens? My ABC is hidden. It means that they are exactly the same. So, my side AB is corresponding to side DE. Side AB is equal to side DE. Then, side AC is corresponding to side DF. That is, they are equal. This is how we write with double-headed arrow. Corresponding AB corresponding to DE, AC corresponding to DF. Same way, side BC is corresponding to side EF. Okay. Now, angle A is corresponding to angle D. I have not written this. Let me write this. BC is corresponding to EF. Now, talking about angles, angle A is corresponding to angle D. Angle B is corresponding to angle E. Angle F is corresponding to angle C. Right? Now, how many informations we have to prove that the triangles are congruent to each other? 6 informations. 1, 2, 3, 4, 5, 6. 6 informations we have to prove that the triangles are congruent to each other. Now, how do I write mathematically? Mathematically, how do I write that the two triangles are congruent to each other? I am not going to write it in sentence. Fine. I am going to use a symbol for that. Now, what is the symbol used? Symbol used here is triangle ABC is congruent to triangle DEF. This is the symbol which we will use for congruence. To represent congruence of two figures, we use this one equal to, on top of that one tilt symbol together. This is called as congruent symbol. Okay. Now, if you see in this, triangle ABC is congruent to triangle DEF. Now, if you take the angles, angle A is corresponding to angle D, angle B is corresponding to angle E, angle C is corresponding to angle F. It is written in the same order, right? Now, we look at the sides. Triangle ABC is congruent to triangle DEF. AB corresponds to DE. As you can see here, AB corresponds to DE, AC corresponds to DF, BC corresponds to EF. That is how it is written. So, triangle ABC is now congruent to triangle DEF. We have 6 informations for that. Okay. This is how we find whether the two triangles are congruent or not. Now, all these 6 informations are not going to be used all the time. Right. Now, as I told you, we are not going to use all these 6 properties to prove two triangles are congruent or not, or whether they are congruent or not. Okay, we are going to use only 3 magnitudes from this, 3 properties from this. That is either there are actually 5 rules of congruence, that is AAS, SAS, ASA, SSS and RHS. All these 5 congruence rules we are going to use, okay, one at a time to prove that triangles are congruent based on the applicability. Okay, that is, we are going to use only 3 information from this. We have got 6 informations here to find out whether the two triangles are congruent, right? Now, we are not going to use all these 6 informations. At a time, we are going to use only 3 informations, that is any 2 angles of one triangle and should be equal to the any two angles of the other triangle. Also one side should be equal to the other triangle. Similarly, SAS in the sense two sides, that is side, two sides and an included angle. This I will explain in detail. Included angle of one triangle should be equal to two sides and included angle of another triangle. Right? Similarly, ASA is two angles of a triangle with an included side should be equal to the two angles with the included side of another triangle. Same way, all the three sides of one triangle should be equal to all the three sides, that is the corresponding sides of the other triangle. Similarly, this is right hypotenuse side congruence, that is right angle. Both the triangles should have one right angle. The hypotenuse must be equal and one side must be equal. Now we will see each of these with one example. Okay. Now the first congruence rule that we are going to discuss is SAS congruence rule. I have taken an example for this. Okay. So before going on to this question, let us discuss what is SAS congruence rule. Say if I have two triangles ABC and PQR. Say if I have two triangles ABC and PQR, SAS, that is two sides and one included angle. For example, my side AB is equal to side PQ, side BC equal to side QR. Okay. The angle in between them must be equal to each other. Side, angle, side. That is, included angle means the angle is in between the sides which we are taking into consideration. Here AB is equal to PQ, BC is equal to QR, and the next angle which I am looking for is the angle which is in between these two sides. That is included angle. Okay. So SAS, the angle is between the sides which are taken into consideration. There is no hard and fast rule that I should take these two sides only always. I can take any other side also. Say for example, side AC is equal to PR, side BC is equal to QR. So which angle should I take into consideration? Angle C here and angle R here. So AC must be equal to PR, BC must be equal to QR, and angle C must be equal to angle R. That is included angle. The angle which is in between these two sides is called as included angle. So that is why we write this rule as SAS. That is SAS congruence rule. Now using this, we are going to solve this question. Hope it is clear what is SAS congruence rule. So these three informations for this rule, these three informations are required for proving that the triangles are congruent. Fine. Now, the question says in a quadrilateral ABCD, now this ABCD is a quadrilateral, AC is equal to AD. AC is equal to AD. See, in geometry we always write what is given, what is to be proved or what is to be found, and then we write the solution or the proof, right? That we have to do, that is compulsory. But it is always better if you mark the given information in the figure. Why? Because by seeing the figure it is easy to solve the question or easy to write the proof. If you are going to depend on the alphabets written on in your given and to prove, it is going to be little difficult. Fine. So now they have given AC is equal to AD. So side AC is equal to AD, and they say that the line AB bisects angle A. What is the meaning of bisects? Bi means two. Bisects in the sense it divides the angle into two equal parts. That is, this angle will be equal to this one. This one will be equal to this one. Two halves. It is divided into two equal halves. Okay. So that is the information given. We have to prove that the triangle ABC, that is this triangle, is congruent to triangle ABD. Okay. Now, as usual, we will write given. What is given? ABCD is a quadrilateral. ABCD is a quadrilateral. And then what else is given? AC is equal to AD is given. And also AB bisects angle A is given. Right? Now, we have to prove that. So, to prove triangle ABC is congruent to triangle ABD. Fine. Now, we'll moving on to the proof. We'll move on to the proof. Consider the triangle ABC and consider. Now we are considering. So initially you should not write they are congruent. We are going to prove that they are congruent. Consider triangle ABC and triangle ABD. So first always write consider triangle ABC and ABD. We are going to prove that they are congruent. Now AC, side AC from this triangle ABC is equal to side AD from triangle ABD. Now, how did I know that AC is equal to AD? Who told me? It is given in the question. See, you have written it in the question. We have even marked in the figure. Right? So, AC is equal to AD. Reason is very important in geometry. Why you are writing that AC is equal to AD? If it is given, write it is given. Or if there is any other reason, you have to write the reason always. Now, AC is equal to AD. Then, if you can see, side AB is common for both the triangles. They are common, so I write the reason as common. The side AB is the base of this triangle also and this triangle also. That side is common for both. AB is there for this triangle also and this triangle also. So, AB is equal to BA. Now, angle BAD, that is BAD from this triangle, is equal to angle CAB. This one is equal to this angle. How? AB bisects angle A. This is given in the question. Fine. Now, I have got three information here. That is side AC is equal to side AD. Side AB is common. And the angle which is taken is between these two sides. This angle is included between the sides that are taken into consideration. So, both the triangles are congruent. Triangle ABC is congruent to triangle ABD. What is the reason? SAS congruence rule. So this is SAS congruence rule. This is how we used to solve the problems. Hope you all understood. Now moving on to the next rule. Moving on to the next congruence rule, ASA congruence rule. Now say I have been given two triangles and I am asked to prove that they are congruent to each other. Now looking at these two triangles, you can make out that angle B is equal to angle Q is equal to 60 degree. Right? And angle A is equal to angle P is equal to 75 degree. Right? Now, side AB is equal to side QP is equal to 4 centimeter. I have told you three information is enough to prove that the two triangles are congruent. Now we are talking about ASA, that is two angles and one included side. The side must be between the angles. Now I have taken the angles into consideration, 75 degree and 60, that is angle B and angle A. Okay, the angles are have a common arm. The angles have a common arm, that is 4 centimeter, which is AB. They have a common arm AB, right? So angle, side, angle, 60 degree. These two angles are equal. Then side, these two sides are equal, and then 75 degree. So in both the cases, the corresponding angle B and Q are corresponding angles, they are equal, and angle A is equal to angle P. The side which is in between these two angles, or you can say they are the common arm of the two angles. It is in between the angles, included side. So ASA. This is ASA congruence rule. This is how we prove two triangles are congruent with respect to ASA congruence rule. Now the next congruence rule that you are going to learn is AAS congruence rule. AAS congruence rule is two angles and one side of the first triangle should be equal to two angles and one side of the second triangle. It can be any side. It need not be an included side. Okay. So in this example, if you can see, angle A is equal to angle P is equal to 75 degree. Angle A and angle P are equal. Angle C is equal to angle R is equal to 55 degree. Angle C and angle R are equal. Now where do you find the equal side? AB is equal to PQ is equal to 4 centimeter. Randomly one side is taken. They are not included. My angles are here, but I have taken some other side, right? Similarly, here also my angles are here, which I have taken into consideration for finding the or proving the congruence, but my side is taken randomly. So this is 4 centimeter, this is 4 centimeter. These corresponding sides are equal to each other. So this is AAS congruence rule. It need not be a included side. Any two angles and any one side from both the triangles must be equal to each other. Then we call it as AAS congruence rule. Now talking about the fourth congruence rule, SSS congruence rule. Here I told you we will consider all the three sides from both the triangles. Now by looking at these figures, you can make out which are the corresponding sides. Side AB is equal to side DE. Both are of 3 centimeter. Then side AC is equal to side DF. Both are of 2.5 centimeters. Side BC is equal to side EF. Both are of 4 centimeters. Okay. So here we are considering three sides. Side AB is equal to the corresponding side DE. Side BC is equal to the corresponding side EF. Side AC is equal to the corresponding side DF. So the three informations that are taken into consideration in this case are three corresponding sides from both the triangles. So triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF by SSS congruence rule. Fine. So this is SSS congruence rule. Viewers, if you have any doubts, you can pause the video, you can rewind the video and watch once again. Further, if you have any doubts, you can mention it in the comment sections. Definitely, I will respond. The next and the final rule which we are going to learn today is Rhs of Congruence Rule. I told you what is this RHS. In the beginning of the session, R stands for right angle. H stands for hypotenuse. And S stands for side. Okay. So here we are going to take into consideration two right triangles. Here we are going to take into consideration two right triangles, ABC and triangle PQR. Both these triangles must have a right angle. That is, since it is a right triangle, obviously one angle is 90 degree. So here I have taken B as 90 degree and here I have taken Q as 90 degree. So angle B is equal to angle Q. Okay. Now hypotenuse, say if this is 4 centimeter, this should also be 4 centimeter. Now before talking about the equality of hypotenuse, now I would like to ask you, what is hypotenuse in a right triangle? In a right triangle, the side opposite to the 90 degree is hypotenuse, or the longest side is the hypotenuse. Now in this, angle B is 90 degree, fine. The side opposite to angle B is AC. So AC is the hypotenuse. In this case, in this triangle, angle Q is 90 degree. So the side opposite, which is the side opposite PR, is the side opposite to 90 degree. So this is the hypotenuse. Hypotenuse is the longest side of a right triangle. Remember this, hypotenuse is the longest side of a right triangle. Hypotenuse is always the longest side of the right triangle. Now here my hypotenuse in PQR is 4 and here in ABC also my hypotenuse is 4 centimeter. They are equal. So hypotenuse AB is equal to hypotenuse PR. Okay. Then say if my base is 2 centimeters, here also 2 centimeters. Base BC, any side, I can even take this side also. BC is equal to QR. So here right angle, that is 90 degree, right angle is satisfied. Hypotenuse from both the triangles are equal and any one side from both the triangles are equal. So by RHS congruence, both the triangles are congruent to each other. So I can write triangle ABC is congruent to triangle PQR by RHS congruence rule. Okay. So this is RHS congruence rule. Now we have learned all the 5 rules of congruence. Now based on this, you will be solving your exercise problems. And in the beginning of the session, I had told you that you will learn some more properties of triangles. So we will move on to that. One main property that you are going to learn about triangles is isosceles triangles. What are isosceles triangles? Isosceles triangle is a triangle in which any of its two sides are equal. Okay, say for example side AB will be equal to side BC. In this case, the triangle is isosceles triangle. Any two sides will be equal to each other. Say this is 3 centimeter, this is also 3 centimeter. Say this is 4.5 centimeter. Now AB is equal to BC. There is no rule that always AB only should be equal to BC. We will take another triangle and check. Okay, say if I have two triangles, if I have another triangle DEF where I have DF is 2 centimeter and DE is 2 centimeter and my base is 4 centimeters. So DE is equal to DF in this triangle, right? So two sides are equal. So such triangles are called as isosceles triangles. Now, the property which you are going to learn is the angle opposite to the equal sides. Angles opposite to equal sides will be equal to each other. Now, in this triangle, say for example, the sides equal are AB and BC. Now, which is the side opposite to, angle opposite to side AB? This is the side, the opposite angle is C. Okay. Now, this is the side BC, equal side, the other equal side. Opposite angle is A. So, in this case, angle AZ will be equal to angle C. Okay, in this case, angle A will be equal to angle C. Now, in this triangle, in this example, if you see, DE is equal to DF, right? So, now I told you the angles opposite to equal sides will be equal. Now, side D, which is the opposite angle? F, right? Side DF is equal to DE. So, the angle opposite to DF is angle E. So, here E and F, angle E and F will be equal. In this case, angle A will be equal to angle C because side AB is equal to side BC. These angles are opposite. A is opposite to BC and C is opposite to AB, right? Similarly, here angle E is equal to angle F because DF is equal to DE. Angle E is opposite to DF and angle F is opposite to DE. Okay. Now, let us discuss the converse of this. Now, what if they give you a triangle, say PQR, and they say that angle Q is 50 degree and angle P is also 50 degree, right? Now, in this case, the converse is, now here you learned that the angles opposite to equal sides are equal. Here you will learn the sides opposite to equal angles are equal. Now, they have given me two equal angles, right? 50-50. Now, let me see which are the sides that are opposite to these angles. Opposite to this angle is side PR, that is QR. Sorry, not PR, QR. Opposite to this angle is side QR. Same way, opposite to angle Q is PR. So, here angle P is equal to angle Q. That implies, we call this as implies. Because of this, QR is equal to PR. They have given me two equal angles. I have taken the opposite side of that angle. Opposite to P is, angle P is QR and opposite to angle Q is PR. So, if P and Q are equal, their opposite sides are also equal. Opposite to P is QR, opposite to Q is PR. This is the converse. So, in an isosceles triangle, what is an isosceles triangle? We just have a recap. Any two sides of a triangle, if they are equal, then that triangle is called as a isosceles triangle. And in an isosceles triangle, angles opposite to equal sides, are equal. Converse is, that is the reverse is, sides opposite to equal angles are equal. This is one important property about isosceles triangles. Inequalities in a triangle. Now, the first inequality that you are going to learn about is, if in a triangle, if you have two unequal sides. So, now I am going to compare side AB and side AC. They are unequal, right? According to the example, they are unequal. Side AB is 3 cm and side AC is 5 cm. Now, the angle opposite to the greatest side will be greater. The angle opposite to the smallest side will be the smallest. Now according to this example, AC, side AC is greater than side AB. Right? So angle C is less than, or I can even write it as angle B is greater than angle C, because angle B is opposite to AC. AC is the greater side, so the opposite angle will be greater. AC is greater than AB, so the angle opposite to AC is greater than angle opposite to AB. So if AC is greater than AB, B is greater than C. Angle B is greater than angle C. Now, if we say this, you can put it in other words, or the converse of this is, say if I have a triangle PQR, and if it is given that angle R is greater than angle P, that is angle R is greater than angle P. If it is given the side opposite to greater angle, that is PQ, is greater than the side opposite to the smaller angle, that is QR. Okay? So the side, if you have a triangle with two unequal sides, the greater side, the angle opposite to the greater side will be greater than the angle opposite to the smaller side. Putting this in the other way, the side opposite to the greater angle will be greater than the side opposite to the smaller angle. Fine. These are the two properties of inequalities in a triangle. And one more thing is, one more concept which you are going to learn is, say if I have a triangle, ABC, sum of any two sides, AB plus BC. Say if I am going to add these two sides, that will be greater than the third side. Okay. Let us take an example. Say if this is 2 centimeter, this is 3 centimeter, this is 2.5 centimeter. 2 plus 3 is 5, right? 5 is greater than 2.5. It can be any two sides. Now I have taken these two sides, AB plus BC, which is greater than AC. Now I can take another side, say AC plus AB, it is greater than BC. So if you add any two sides, that will be greater than the third side. Now how much is your AC? 2.5 plus your AB is 2, greater than 3. 2.5 plus 2 is 4.5, that is greater than 3. So from this it is clear that when you add two sides of a triangle, it will be greater than the measurement will be greater than the third side. AB plus BC is greater than AC. AC plus AB is greater than BC. You can even say that AC plus BC is greater than AB. So these are the concepts that are there in this chapter, which I have explained it completely. Based on all these concepts only, we are going to solve the exercise problems. Hope it is clear to you all. If you have any doubts, you can mention in the comment section. Thank you.